Next in line, cranial nerve number 2, the optic nerve. The optic nerve is a special sensory nerve. It serves the sense of vision. It'll leave the posterior aspect of the eyeball by going posteriorly and medially. It actually leaves the orbit via a hole in the sphenoid bone, which is called the optic canal. Let me highlight that here. About half of the fibers, so approximately 50% of the fibers, will actually switch over or cross to the other side in the optic chiasma or optic chiasm, and then they will continue back to the brain. The part of the visual pathway from the optic chiasm to the brain is termed the optic tract. Technically, however, if we're precise about it, even the optic nerve is actually a tract itself, because the retina is developmentally an outgrowth of the forebrain. Next in line is our cranial nerve number 3. Cranial nerve number 3 is the oculomotor nerve. Let me see if I can indicate it here. And as usual, the name is the game. That means that oculomotor means it is a nerve that supplies motor function to the extraocular muscles. Not all of them, but the majority of them, as you might already know. In addition to supplying motor fibers to these extraocular muscles, it also supplies proprioceptive innervation to the same muscles, so that basically the position of the muscle, which results in the position of your eyeball, is actually always known. And last but not least, cranial nerve number 3 is one of those 4 cranial nerves that also conveys parasympathetic fibers. So in that case, we have visceral innervation that goes via the ciliary ganglion to the smooth muscles of the sphincter pupillae muscle, which causes the constriction of the pupil. It's a sphincter. And also the ciliary muscle, which is the one that changes the shape of the lens. We need that to produce accommodation. So that'll actually allow the lens to become more rounded for clearly seeing objects that are close to you. So our oculomotor nerve emerges from the midbrain, pierces the dura, runs through the roof and the lateral wall of the cavernous sinus. That will be right about here. So it's actually embedded in the dura. We had to hide the rest of the cavernous sinus or the venous system here. And then it'll actually continue its way by passing through the superior orbital fissure. And within the fissure, it'll divide, first of all, into a superior and inferior division. The superior division will supply the muscles levator palpebrae superioris. This one elevates the upper eyelid, levator, elevate, palpebrae, that's the eyelid, superioris, the upper eyelid. So LPS, it's abbreviated as well. It also innervates the superior rectus, and it also divides into an inferior division. And if we look at the inferior division, you can see nerve fibers that are going down here. So the fibers of the inferior division will supply the inferior and medial rectus. The medial rectus is here, the inferior rectus is here, and the inferior oblique is right there. The parasympathetics, that will have an effect on the pupil, be that either in changing the shape of the lens or the size of the opening of the iris. They will synapse in the tiny little ciliary ganglion, which is actually posterior to the eyeball, about a centimeter behind it. It is a tiny little parasympathetic ganglion, which I would recommend is best to be reviewed either in a book or on a cadaveric specimen. Next up is cranial nerve number 4, the trochlear nerve. So the trochlear nerve is probably one of the easiest or simplest nerves there are because, well, apart from the abducens nerve, this nerve actually only innervates one muscle. And the way that I like to remember it is, well, the trochlear nerve goes to a muscle that actually runs through a trochlea itself, and this muscle is named the superior oblique. Yeah? So you can see the trochlear nerve runs and innervates the superior oblique, so it provides both motor and proprioceptive information to this muscle. And this little protrusion here is a trochlea. It's like a pulley. Yeah? So it redirects the pull direction of the superior oblique muscle. And that's why learning the actions of the extraocular muscles is very daunting to many. And now that you can see how at least the superior oblique attaches, there's also an inferior oblique, as we're going to see. Well, it makes it a little more difficult, but nothing's impossible. So anyway, your trochlear nerve is the smallest cranial nerve, and actually comes from a region which is called the nucleus of the trochlear nerve, and it'll cross the midline before it emerges below or inferior to the inferior colliculus of the posterior surface of the midbrain. Okay, so if we were to grab the model here, you can see how little that nerve is running along here. And then it passes anteriorly. Let me see if I can zoom out a little bit. So it goes around the brainstem, and it pierces the dura, which we've had to make invisible for this slide, otherwise we couldn't really see. And it also runs through the lateral wall of the cavernous sinus. See this region here? This is the cavernous sinus on the right side. This here is the sella turcica with the pituitary in it. And this nerve also runs through the lateral wall of the cavernous sinus. It'll then continue and pass also through this opening here, the superior orbital fissure, which is outlined in blue. And as I've already indicated, it then supplies the superior oblique. That's all it does. Very nice and straightforward. Alright, so now we're going to be looking at a nerve that is a little bit more elaborate. This nerve would be the trigeminal nerve. Okay, the trigeminal nerve emerges from the lateral aspect of the pons back here. It actually has a large sensory root and a small motor root as well. They're not actually indicated on this model, but know that the trigeminal nerve both has sensory and motor components. In general, it is actually called the great sensory nerve, but the motor components are very important as well because the trigeminal nerve innervates, for instance, all of the muscles of mastication. In addition to that, 2 other small muscles as well, and they're called the tensor tympani and the tensor villi palatini. The main sensory function of the trigeminal nerve is to provide general sensory information for the head, so that includes your face, teeth, mouth, nasal cavity, and the dura of your cranial cavity. Yeah, so if someone has like a dural headache, well, that's actually mediated largely by fibers from the trigeminal nerve. Okay, so the sensory root of the trigeminal nerve, let me highlight the trigeminal nerve itself, okay, is actually composed mainly of central processes of neurons in the trigeminal ganglion, which is directly next to it. And you might also hear other names for this ganglion. Some people call it the Gasserian ganglion. Some people call it the semilunar ganglion. Maybe they believe it looks like a half moon. Anyway, trigeminal ganglion is the most usual anatomical term for it. So the peripheral processes of the ganglionic neurons are going to divide